Okay, I will start recording because now we will start to start our lessons. Okay.
Mister,
Yes.
I don't know why my camera isn't turning on.
Oh, you're gonna turn on your camera?
Yeah, it's like showing this weird thing.
Oh, okay. Okay, it is no problem. You can fix it later and just focus for the lesson today, okay?
Okay.
Okay. Let me share my screen. Okay, do you see my screen? Okay, do you see my screen, Reynald?
Um, yeah,
Yes, okay. So, yeah, this is our first lecture. Let me, before we start, let me describe what will you learn? Mm, okay, wait. What will you learn in the eighth grade? Okay, I will add it in the end of the notes.
yeah,
O- Okay, so basically, in eighth grade physics, you will learn about classical physics.
yeah,
Okay, do you know Newton?
yeah, I know.
Yeah, Newton. So basically, especially in the eighth grade, you will learn about um, Newton's law. This is for mechanical physics. I say mechanical physics because in the future you may learn about, let me say, electrical physics, magnetic physics, and etc. But for eighth and I think ninth grade, you will learn a lot about classical physics, especially about Newton's law. And then before we go to the Newton's law, this is the first basic theory that you need to learn and understand about the classical physics. That is about mass, weight, and density. Can I ask you what is your physics topic at your school?
Energy, I think.
MI3A?
Energy.
Energy? Okay, have you learned about this one?
I just learned energy like a week ago.
Okay, wait. I need to reshare my screen. Okay, but have you learned about mass, weight, and density?
Yeah,
Okay, so I think for today we will uh, review for this one if you have understood about the mass, weight, and density. So in this time we'll just review for you, and next time we will go to the energy. Also, have you learned about? Let me wait. Speed.
what'd you say, sir?
Have you learned about speed and force?
Yes.
Yes. Okay. Very good. Okay. Then, if you have something like quiz, homework, or exam, you can discuss with me. Just tell me, okay?
Okay.
Okay, so let's start. Okay, we start from the mass. Okay. The important one is you need to be able to differentiate between mass and weight. Why? Because mass and weight is a very different concept, especially also density. Also, okay, mass is defined as a measure of quantity matter in an object relative to observer. Relative to observer, and then mass is affected by volume. So the implication is if you have the same thing but your volume, the volume is different, so therefore your mass will be different. This is the key point. And then uh, the the mass will not affect it by where the object is observed. So what I want to try to say is, if you measure your mass, you measure your mass on Earth and on Jupiter, Saturn, or Moon, you will get the same measurement of your mass. So mass is mass. You cannot. It is specific for its material, and mass just affected by volume. Okay, you just need to pay attention for here. Mass is only affected by volume. Okay, and then this is the conversion of mass. So usually, on the for the calculation, we just use milligram, gram, kilogram, and ton. But ton is very rare. This is rare. Okay, this is the three important. Okay, and I hope you have learned about conversion, like from milligram, gram to kilogram on your mathematics. It is same like if you convert from meters to centimeters or millimeters or to kilometers. This is the same concept. Okay, and then let's continue to the weight. Okay, weight is a gravitational force on an object with mass. Okay, so this is the this is the key point. Weight is a force and it is a vector. Okay, so do you know the difference between vector and scalar?
I forgot.
Okay, I will explain to you. Okay, vector, okay, here. Vector versus scalar. Okay, here. Vectors have direction and mass. However, scalar only have mass. No, no, not mass. Quantity. Only have quantity. Okay, for example, what can I say? Length. Okay, length. Let's say you measure a yard. You measure this one to this one. This is the width. And then let's say this is the side. Okay, side width. Usually you measure it in meters, let's say in meters. Okay, so here, if you measure, okay, the area of the yard, it is, let's say, 50 meters squares. So that's all. This is just a number, just a measurement. You don't have any direction, but it will different if I talk about, let's say, force. Okay, let's say this is a floor, and then I have a box here. Okay, let's say I have a box here, and then let's say the box have mass m. Okay, and I want to try to push this box. Okay, let's say there's people here. Okay, stickman. Yeah. Okay, let's say the stickman want to push the box. So the stickman need to give a force, let's say 50 Newton, to move the box. If you give force below the 50 newtons, the box will not move. Okay, and then if you concern here, you also can pull the box. So to move the box, you have two direction. Okay, to move the box, you have two direction. Pull or push. Okay, this is what we are talking about vectors. So beside we have a quantity that is 50 newtons. This is the quantity. We also we also have a direction. Why? Because if you give like let's say 60 newton. Okay, if you give you 60 newton to the box will move. But which direction the box will move? It depends on your directions. If you push the box will move here. This is push. But if you pull the box will move in the different direction. This is for pull. That's why in vectors, direction is very different. That's the point. Okay. Do you have any? Do you get it? Do you have any questions?
Um, no.
No.
Yeah.
Okay.
It.
Also, if you have questions during the class, you just can directly interrupt me. Okay. Do not wait until I finish talking. Okay.
Okay, sir.
Okay. So here, let's continue. Okay. Weight is measured in newtons. Of course, there is a conversion. Usually, you will convert between newton and kilonewton. Just these two. There are there's no not there's no there is millinewton, but usually people do not use millinewton. Why? Because 1 newton is a very very small quantity of force. So usually people use newton or kilonewton. Okay, and then as mentioned before, weight is affected by gravitational force. So the weight is influenced by where the object is observed. So if you measure your weight in on Earth and on the moon, you will get different weight. Why? Because the gravitational force on the moon is uh, weaker than on the Earth. So that's why if you ever see like a sci-fi movie, and then you will see like an astronaut will floating in the moon surface. This is that's because the gravitational force of the moon is very very weak compared to the Earth. So let's say your weight on Earth is 60. If yes 60, maybe on the moon you will just get, let's say, 10 newton. Okay, so okay, if you measure your weight, like let's say you go to the hospital and the nurse asks you to measure your weight. My question is it mass or weight?
Mm.
If you go to the hospital and then the nurse asks you to, okay, measure your weight, it is actually a weight or a mass?
Um.
Um, Mass.
Mass is it is a mass. Why? Because your unit is kilogram, right? You never
Yeah.
you never like say your weight in Newton. Okay, my weight is 60 Newton. No, people will not understand for it. Just just for some people will understand it. So basically, if you measure your weight, it is not a weight. It is a mass. Okay, and then you need to pay attention here. Okay, just always remember the units. Okay, because units is very important. Weight is Newton. And then for mass, the unit is kilogram or gram or milligram. Okay. Okay, let's continue. Okay, so let's continue. The gravitational field strength is defined as force per unit mass acting. Okay, so this is the formula. And I think you have learned about this one, and I think you remember about this one. Do you remember?
What did you say, mister?
Okay. You can remember now because in the end of this class we will have a practice. Okay, and
Okay.
then in a triangle you can write it as weight. Okay, let's draw the triangle, weight, and then this is mass and gravity. Okay, so gravity is a constant. Okay, usually we don't look, we are not looking for about the G, the gravitational field strength. Why? Because the gravitational field strength, this is influence if you measure in in a space or outside the Earth. So as long as you do your experiment or measurement in the Earth, you will have the same value of G, and the value of G in Earth,
Uh,
G is 9.8 Newton per kilograms or 9.8 meter per seconds square. Okay. Okay. Do you have any questions?
no, sir.
No. Okay. And then, okay, so this is the summary for mass and weight. Okay, so object mass always remains the same. Okay, for the same volume, your mass will always same. Regardless of its location in the universe, mass still same in the same volume. Okay, and then if you measure a weight force, it will differ. It can be different depends on where are you measuring it. If you measure on Earth, of course, it will different if you measure on Moon. Okay, so this is for the example and the notes. Okay, and then okay, let's continue from the text first. Okay, number one, an object has a mass for 45 grams. State the mass of the object in kilograms and milligrams. Okay, 40, 45 grams. Okay, how much 45 grams in kilograms?
Uh, uh, a 100, I think.
100.
No, 1,000.
1,000, you divide or multiply with 1,000.
Divide.
Divide, yes. Okay, this is like stairs, this is gram, this is kilograms, this is milligrams. So if you down here, you need to multiply with 1,000, multiply with 1,000. But if you upstairs here, you need to divide with, wait, divide with thousands. Also this one divide with 1,000. Okay, so 45 grams is, okay, what is 45 divided by 1,000?
Um, can I use
Zero.
calculator?
Okay, 0 point. We want to move from here, from gram here to kilograms. So we need to divide with 1,000.
Zero. Is it 0.045?
Yes, very good. 0.045 kilograms. Okay, nice. How if I want to convert to milligrams?
Hmm. Uh, how do you
So
do it, sir?
okay, so you want, okay, just look at the stairs and then look at my pen. Okay, you want to move from gram to a milligram. So we need to multiply or divide.
Hmm.
We need to multiply with 1,000, right?
Yeah.
Okay, so
So it's 45 milligrams.
okay, 45,000 milligrams. Okay, so for a gram, for a mass, you just need to pay attention with this letter, with these
Okay.
stairs. Okay, you don't you will not use like centigrams. There is no people who use centigrams. It's a freak. Okay,
Okay.
so usually people just use kilogram, gram, and milligrams. Okay, let's continue. Okay, number two, a 1 kilogram sample of aluminum is stored in a laboratory. Okay, and so in the first case, I have 1 kilograms of aluminum, and in a different laboratory in the same town, in the same planet, there is a 1 kilogram sample of iron. Which quantity must these two samples always have in common? Okay, so let's say I have a same box, a big box, and then I have wait, and then I have aluminum. Okay, the
Yeah.
symbol is Al, and then the other one is iron, which is Fe. Okay, this one has same mass. Okay, same mass, which is 1 kilogram. Okay, which quantity must these two samples have in common? Okay, can you guess? A, same density, B, the same temperature, C, the same volume, D, the same weight. The same weight.
Um. Hmm. Um. Same density. I don't know.
Same density. Okay, okay. Yeah, this is something like tricky, a little bit tricky. Same density. Okay. The
Is
formula.
this the weight?
Hmm? The
It's
weight.
the
Yes,
weight. Oh,
yes. The correct answer is the weight.
I didn't see the same as.
Yes, because the formula for the weight, W, is mass times the T, right? And the T is affect affected. Okay, not affected weight. different when you measure outside the Earth. So, if you measure 1 kilogram of mass, 1 kilogram of iron, you measure 1 kilograms of book, you measure 1 kilograms of laptop, you measure 1 kilograms of water, the weight also same. It will around 10 newtons if you use the gravitational is 10. Okay, so this is the same weight. Okay, the same density. Okay, I think this is something tricky. Same density, yes, it could be same density if the sample of aluminum and the sample of iron has the same size. Okay, but I guess 1 kilogram of aluminum will different with 1 kilogram of iron. Okay, so because in our information, in our question, there is no statement of the aluminum has different, has a same size, has same volume with iron, so we cannot just the aluminum and iron have the same density. And the most correct one is the both of them has the same weight because this formula. Okay, do you have any questions?
No.
No? Okay, so I will take note for you here. Every phenomenon always
Mm.
can be explained using physics formula. Okay, what I mean is like question number 2. You don't need to calculate anything, but uh, almost of people cannot answer these questions fastly. Why? Because they just remember, because they just know how to calculate. But the important one is physics is not just a calculate. Okay, this is physics. This is not math. So, in physics, understanding the formula is the most important. So, if you understand the formula, if you remember the formula, you will be able to answer non-calculating questions. Okay,
Okay.
next. Okay, number 3. NASA's Artemis mission aims to send the first woman astronaut to the moon. Okay. Isabel hopes to one day become an astronaut. She has a mass 42 kilograms. Okay, this is our first information. Her mass is 45 kilograms on Earth. Okay. And then we are asked to no, not okay. We are asked to compare Isabel's weight on Earth with her weight on the moon. Okay. So the question is we are asked to compare weight on Earth and moon. Okay, this is the main questions. Okay, and then the last informations. Earth's gravitational field strength is 9.8 Newton per kilograms, and then moon gravitational weight is 1.6 Newton per kilogram. Okay, let's compare. Earth. Okay, let's say the weight on the Earth is W E. E for Earth. Okay, so what is the formula of weight?
Mm. I kind of forgot, sir.
Okay, here you have formula in above near number 3.
It's like Um,
This one, right?
there's like the newtons and like the mass
Mm-hmm. Mass times.
times wait. uh,
G.
Okay.
Gravity.
Uh,
Okay. Okay. I forgot to tell you. You can say G is as gravity.
Uh,
Okay. To shorten our pronunciation, you can call G as gravity. Okay. So weight is mass times gravity, right?
yeah.
Okay, gravity. But which gravity is it? Moon or Earth?
What did you say, sir? I didn't
Uh,
hear.
okay, which
My
gravity? Which
Wi-Fi
gravity?
is a bit bad, sir.
Okay, okay, no problem. I will repeat it. Okay, we are doing the weight of Isabel on Earth. Okay, and then you have mentioned before like the weight formula is mass times gravity. Okay, but here we are uh, which gravity are we talking about? The gravity of Earth of or Moon?
um, gravity of the moon.
Moon? We are talking about Earth here.
Uh,
Okay, so the gravity is Earth gravity. Okay,
yeah.
okay, very good. Okay, let's calculate it. Okay, so how much is the mass? How much is Isabel mass?
Our mass 42 kilograms.
Okay, 42 kilograms times how much is the Earth gravity?
Uh, 9.8 newtons per kilogram.
Okay, 9.8 newtons per kilogram. Okay, can you help me to calculate for 42 times 9.8?
Uh, okay.
Okay, this is also exercise for you. I also calculate it. We can compare our answer.
Uh, 411.6.
Okay, 400. Okay, very good. 411.6 Newton. Okay, why Newton? Because we can cancel the kilograms and kilograms here. Okay, number. Okay, and then let's calculate the weight on the moon. Okay, moon. The weight on the moon is WM. M for the moon. Okay, mass times gravity on the moon. Okay, what is the mass? How much is the mass? Same, right? 42 kilograms times. Okay, what is the gravity of the moon?
1.9 newtons per kilogram.
Okay, 1.6 Newton per kilograms. Okay, can you help me to calculate it?
Okay. 67.2.
Okay, I got the same answer. 67.2 newtons. Okay, we can cancel the kilograms here, so it left for Newton. Okay, so what can we take for conclusion from this calculation? Which is Which is more heavier? Which is heavier? The weight in the earth or on the moon?
The Earth.
The earth. Okay. So that means the way if you measure your weight on earth, it will heavier than the weight on the moon. Okay. So that's the answer for number 3. Okay. You have any questions?
No, sir.
No? Okay. Let's continue for the last concept. Okay. The last one is density. Okay. I will not take long time for density because we just have around 15 and 20 minutes before the end. Okay. Density. Density is defined as mass per unit volume, yeah, because this is the formula. Okay, this is the important one. Density is a specific weight. Okay,
Yeah.
specific weight. So in maybe in a physics or in a chemistry letter, you will find words like specific weight. Okay, so if you find words specific weight, it means for density. And then this is the formula for density. Density is mass per volume. Okay, and then density. Wait, I think I have write it here. Wait.
Hmm.
Okay, just I will. I think I forgot to write it. Okay. Oh, this one. Density is characteristic of materials. Okay, so mm, characteristic of materials mean if you have different materials, you must have different density. Let's say you have um, one mass, not one mass. Okay, let's back to 1 kilogram of aluminum and 1 kilogram of iron. Okay, they have the same, they have the same mass, but they will have different, not will, they have different
Uh,
density. Yes?
Never mind, sir.
Okay. Okay, I think you asked something. Okay, so this one. 1 kilogram of aluminum and 1 kilogram of ferrous or iron. So they have the same mass, but they must have different density. Why? Because they have different volume. Okay, and then this is the formula for density. Density is symbolized with rho. Okay, you call this one as rho. Okay, and then in triangle, we can use this one. If you want to easy to remember the formula, you can use the triangle. Mass, rho, and volume. Okay, so, okay. From density, you will go to the further concept. It is float and sink. Okay, so float and sink. You maybe I don't know you pay you make attention or not, but if you if you if you put something things, yeah, something in the water, so it has three possibilities, or two, you can say two possibilities. It will float or sinks. Okay, and then actually, honestly, the float and sink phenomena is depend on the density. So if your density of your materials of your thing is heavier than the water, it will sink. But if it is lighter than the water, it will this one. It will float, and then if the density is like similar with the water, it will not fully sink, but it also will not fully what can I say, float. It will not float on the surface. So this is something like, so yeah, something like this one, like the wooden blocks. So
Uh,
yes.
Nothing, sir. I just saying.
Okay. Okay, so iron block. Okay. The density of iron block is heavier than density of water. That's why it will sink. And if your density of polystyrene can be uh, abbreviated as PE. Okay,
Yeah.
PE lower than water. That's why it will floating. Okay, this is the concept. Okay, do you have any questions?
No, sir.
No. Okay, so let's continue for this one. Okay, number 4. Mrs. Chang measured her weight on the moon, and it is 80 Newton. Okay, let's continue for this one. What is Mrs. Chang's weight on the Earth? Okay, to measure the weight on the Earth, you need this formula, right? Weight equals to mass times gravity. Okay, do you remember? Okay,
Yeah.
okay. But do we have any information about mass?
Uh, yeah.
Okay, where
Wait.
where can where can we
Is
find
the newtons?
the
Uh,
what?
uh, is it gravity here?
Okay, to
Is it
measure to
gravity?
measure the weight on the Earth, we need to use this formula, right? Mass times gravity on Earth.
Yeah.
But do we have any information about mass? About the mass?
Is it 80 newtons?
Okay, 80 Newton is a weight, right? Not a mass.
Uh,
Okay, so we need to find the mass. Okay, and we can find the mass from the weight of the moon. Okay, we can find the mass from this information. Okay, so let's check it. Okay, weight on the moon.
yeah.
Okay, the weight on the moon is Vm equals to mass times gravity of the moon, right?
Yeah.
Okay, and then what is the weight on the moon? How much?
Wait. Could I calculate it first?
Okay, it is 80, right?
Yeah. So
80 Newton equals to mass times, let's use the gravity as 1.6. 1.6 Newton per kilograms. Okay, so your mass will be 80 divided by 16, right? Not 16, 1.6. Okay,
yeah.
okay, can you help me to calculate?
Okay. Uh, 50.
50. So Mrs. Chang weight is 50 kilograms, and you can use 50 kilograms if you measure her weight in the moon, in the sun, if in the sun if we can, but 50 kilograms will 50 kilograms everywhere. It will not change. Okay. Then let's check for the Earth. Okay, so from the Earth we use the same equations. V W of E for Earth equals to mass times the gravity on Earth. Okay, so the weight on the Earth is mass. The mass is 50 kilograms. And then the gravity on Earth, let's use 9.8. 9.8 Newton per kilograms. Okay, can you help me?
Okay.
Okay.
Mm. It's 490.
Okay, 490. What is the units?
Mm, I think it's
Okay, what is the
Newtons.
yes, newtons.
Oh,
The units for weight is always newtons. Okay? Do not
um,
don't be confused. It will always be newtons, okay?
so like the weight is always Newton.
Yes, the weight is
Uh,
always newton. Okay? Or you can if you confuse, you can look from here. This is why I always I thought if you look here, if you look during I calculate all of the practice, all of the questions, I always write the units, right? I always write the unit here.
yeah.
Kilograms. Newton per kilograms. Newton. Kilograms. Newton per kilograms. Newton. During the calculation, I always write the units. I don't write the units only in the end of the final answer. Why? Because it will prevent me to forget what is the unit, okay? If you write the units here like 50 kilograms times 9.8 Newton per kilograms, this is something like you can operate your number, but also you can operate your units. This is I think this is something new for you. You can operate your units. Okay, just okay.
Yeah.
This one. This is something like if I have kilogram, I times with Newton, and I divide with kilograms. This is something like 2 times 1 over 2. You can cancel the 2, right?
Yeah.
And what you have 1 here. This is also same. You can cancel your kilogram, and the left is Newton.
Oh, yeah.
So by writing your units during the calculation, it will prevent you to forget the final units. Okay,
Okay.
just always write the units. Okay, let's continue. We still have 3 more. Okay. Okay. A puffing slab has a mass of 73 kilograms and the dimension of 0.04 meters times 0.5 meters times 0.85 meters. Okay, calculate the density. Do you remember the formula for density? Density is rho.
Uh, it's like I
M?
forgot.
Okay, okay, let's check together. Oh, this one. Density, rho,
Uh,
is mass divided by
mass.
volume. Okay, keep it. Mass divided by volume. Okay, we have mass here, but we don't have the volume. So That means we need to calculate the volume. Okay, volume. This is volume of cube. Yeah, I think this is like a box. Okay, so it will length, not length, width times side time height. Okay, let's say 0.04 meters times 0.5 meters times 0.85 meters. Okay, can you help me?
Is it wait, the calculator is not turning on. Wait,
Okay, no problem.
this is my phone. 0.017.
Okay, very good. I got the same answer. 0.017 meters cube. Okay, because this is meters time meters time meters. So we have meters cube. Okay, let's put it to the density formula. Rho meter divide or not meter, mass divided by volume. Okay, so the density is 73 kilograms divided by what?
Uh, Where's the volume?
Mass divided by the volume. The mass is 73 kilograms and
0.017.
okay, very good. 0.017 meters cube. Okay, can you help me to calculate it?
Okay. Uh, is it 4,294.12 kilograms?
Yes, I get the same answer. 4,294.12. Okay, what is the unit?
Uh,
You can
is
look from the calculation.
kilogram for a kilogram meter square.
Meters cube.
Uh,
Okay. 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 This one. Kilogram per meters cube. Okay, let's continue. We want to convert it to gram per centimeter square. Okay. This is how we convert the density from kilogram per centimeter per kilogram meter square to grams per centimeter square. Okay, the density is 4,294 0.12 kilogram.
Yeah.
Kilogram per meter cube. Okay, my question to you is 1 kilogram is how many grams?
Uh,
If
1,000.
yes, 1,000 grams. Okay, 1,000 grams. Okay, here. This is how converted 1,000 grams. Okay, and then if I want to convert from meters cube to centimeters cube, I need to multiply how much?
What did you say, sir?
Okay, I want to convert from meters cube to centimeters cube.
How do you do that, sir?
Okay, wait, wait. Okay, this is gram. Okay, if we want to convert from meters cube to centimeters cube, okay, this is something like this.
Mhm.
This meter, decimeters, centimeters. If you want to convert from meters to centimeters, we need to times with 100, right?
Yeah.
Okay, but this is just for meters to centimeters because we have meters cube, we multiply with 100 power 3 centimeters cube.
Yeah.
Okay. Okay, do you have any question for the converting?
Uh,
I think
Is it
if you have if you still confused about convert from cube and square, we can learn it next week. Okay?
okay, sir.
Okay, no problem. Okay, can you help me to calculate this one? This is 4294.2 times 1000 divided by 123 gram per centimeter cube. Okay, can you help me to calculate this one?
0.001.
Okay, 0.001.
And
So,
like times it.
mm-hmm.
Uh, so it's 0.1.
Okay, so the answer is 4.19. Okay,
Um,
if you calculate the whole this one, you will get this one. You can check it later. This is gram per centimeter square, not square cube. So this is how we converting from the kilogram per meter cube to gram per centimeter cube. Intensity, we usually just use kilogram per meters cube or gram per centimeters cube. Okay, do you have any questions?
no, sir.
No? Okay. So we still have two more. We can do it next week. So okay, that's all for today. Do you have any questions? No?
What's the formula to like weight again?
Okay. So if you have any questions, you can keep or you can take note your questions because I also will share this PDF to your mom, and then if you have any questions you can keep it or you can note it, and then you can ask me for next week. Okay.
Okay.
Okay, so that's all for today. Thank you. Bye bye.
Yeah, thank you, sir. Bye.
Thank you. Bye bye.